Hello, welcome everybody. Here is your lesson on complex numbers. Complex numbers are defined with this letter I. I is defined to be the square root of -1. And if you square I, that's defined to be just -1. These are kind of your definitions that you're going to use in this lesson. And we'll talk about how to do these problems, and then we'll talk about a little bit of application. So the first problem here, example number 1, you're going to solve for x the same exact way you solved for x in the past. And that is, since it's x squared, to get rid of a square, you square root both sides. So the square and the square root cancel, and you get x equals, don't forget, whenever you take a square root, you get a plus or minus answer. Now, you get the square root of -16. Now, the square root of -16 can be thought of as the square root of -1 times 16. Now, you can do the square root of 16. The square root of 16 is 4, so x equals plus and minus 4. Now, that's how you get the 16 out of that square root. Square root of 16 is 4, because 4 times 4 is 16. You happen to be left here with the square root of -1, and by definition, that is our letter I. So it ends up to be plus and minus 4i. Now, this is a kind of a more complex branch of mathematics, hence the name complex numbers. And there are not a lot of applications of complex numbers, but the most wide variety you'll see complex numbers is if you ever were interested in becoming an electrician, electrical engineer. I happens to deal with current, and it's a way mathematicians got around this issue of having a negative square root. So if you ever take an electronics course, you'll definitely encounter I, and sometimes in the electronics course, the I is called a J instead of an I. To move on, here's example 2. Same thing, you're just going to be solving here for x squared, but sometimes you have to do something first. In this case, you have to divide by 2. You get x squared equals 48 divided by 2 is 24, and it's a negative number. Then to get rid of the square, you square root it. Now, square rooting a number that's not a nice even square root, like 25, it would be 5, or 16 was 4. This one's 24, so we're going to have to kind of simplify this problem, which you may have done in your previous math classes. There's lots of ways to simplify it. One of the ways is to bring that -1 out so you don't have to worry about that. That'll become I in a moment. And then the quicker way is to come up with a perfect square that gets multiplied to get 24, and that happens to be 4. 4 times 6. So if you change this to 4 times 6, you're going to end up then saying this is your I. The square root of 4 is 2. The 2 normally goes in front of the I. And then you have this leftover 6, and you can't do the square root of 6, so you leave it as a square root of 6. Don't forget your plus and minus. Now, there is an alternative way to do this, and that's the break it down method. That's the method I like because it always works. You could break down 24 into its counterparts, 4 and 6. Break this down into 2 and 2. Break this down into 2 and 3. And then you have your -1. You have 3 2's and a 3. And then I believe I might have referred to this before as the break out of jail method. If you have a square root and you have a friend, here's a friend, they can break out of jail. And I happens to be like a secret agent. He can break out of jail too. So the 2 2's come out and make 1 2. The -1 comes out and makes an I. And the 2 and 3 are left over, and 2 times 3 is 6. You get the answer either way, whatever you feel comfortable with. If you're good with perfect squares and knowing that you're looking for 4s, you're looking for 9s, you're looking for like 81s, 36s, if you're good at that, then you can certainly pick that method. As we're moving on here, now we're going to be using mathematical operations with I. The first one is multiplication. Now, you treat this problem the same way you treat normal problems with x's, and you just have like 2x times 3x squared, and that would be 6x cubed, but in this case it's an I cubed. By the first slide, I happens to be, by definition, square root of -1, and if you remember correctly, I squared, by definition, is just -1. So anytime you have an I power that's bigger than 2, you can break it down into I squared times I. You'll want to keep that separate. The reason why you want to keep that separate is you're looking for I squareds. Why? Because I squareds by definition is negative 1. So 6 times negative 1 times my good old friend I. Negative 1 times 6 is negative 6. Your answer is negative 6I. This complicated initial problem ends up to be this. Now, if you remember correctly, I'm not sure if you remember from earlier in the year, but when you took that placement exam, there was an I or question or two on that exam. So this is kind of an important concept for college placement tests. You could also have an addition or subtraction of I stuff. I don't like to subtract. I always like to change it to plus. That means then the 4 becomes negative and the I becomes negative, like we did with x's a couple sections ago. And then you just add like terms. 2 and negative 4 is negative 2. 3i minus 1i is plus 2i. And there you have it. Moving on, you got a multiplication problem. I've got 2 left. You can kind of see that these problems go fast. This is just your good old FOIL problem. So I'm going to do my first, 6. My outers, 3 times negative 7 is negative 21. Your inners, 2 times I is 2i. And your last, 7 times 1, I guess, is negative 7, and then I squared. You do have your like terms in the middle. You combine them like you normally would with a polynomial, negative 19i. And then you take this guy out on the end. And then I squared now, this guy here, by definition, is negative 1. Anytime you see an I squared, you need to replace it with negative 1. And sometimes it's hidden, like I cubed on that one problem. You have to find those I squareds. Then you have a multiplication here. So negative 7 times negative 1 is positive 7. And then like terms are 6 and 7. They're both plus now. So 6 plus 7 is 13. 13 minus 19i. One comment about the way to write i's in this complex form. Usually the I comes second instead of coming first, like it would in a polynomial if it was an x. It doesn't have to be done that way, but you'll always see it on an ACT test or something like that. Last problem. This is just a simplification in terms of division. This one you would treat the same way you would treat as if it was an x again. You take these two guys and separate them. You get 4 over 2i minus, changing colors here, these two guys on top of each other. 8i over 2i. It's just splitting them. You can only do that when you have one term in the bottom. Then you simplify. 4 over 2 is 2. I stays on the bottom. Minus 8 over 2 is 4. And the i's cancel, and you get 2 over I minus 4. That's your lesson with I operations. Thanks for listening. Have a Merry Christmas, everybody.